Welcome everyone. This is we're gonna get started with the GTAP virtual seminar series. The topic of today is a general equilibrium model with an asymmetric Armington function, method and application. I believe we're gonna be beginning the seminar with Martín Sicovies. He is a researcher in the Centro de Estudios Distributivos Laborales y Sociales en la Universidad de La Plata. Welcome, Martin. I think Hans Lofgren, the co-author of this paper, is going to be joining us soon, and I believe he's going to beginning second. He's going to be the second presenter of the same, the both co-authors of the same paper. And as a general rule, please mute your microphone. Otherwise, we will have you mute. There is Hans. Hey, Hans, good to see you.
Hello. Morning.
Morning. And there's Martin as well. Good to see you, Martin. I think you're wearing the same shirt, more or less, the uniform. And anyway, so the rules of engagement, the presenters will have about 20 to 30 minutes. I mean, we can be a little bit more flexible on that. I won't take much more time. And if the people in the audience have questions, please feel free to use the chat box to raise your questions as they happen. And if not, then at the end of the presentation, we'll have some time for question and answer, so for a discussion with the author. So with that said and done, yeah, I mean, the last bit of information that you should know is that the seminar is being recorded and will be posted afterwards with the presentation files. Do you want to take over the controls, Martin, for the presentation, or do you want us to handle it from here? Or Hans?
Yeah, actually, Hans will be the first one.
Okay, sorry, I got it all backwards. Okay, then Hans, do you want to take control, or do you want me to load the presentation?
Okay, I will start, I think. Okay, yeah, now let's see here. It says you cannot share the presentation while others are sharing their screen.
Can you try it again? I just stopped.
Yeah, oh, okay, very good. Okay, so let's see here.
Yes, it can be seen. Yep. Can you put it presentation mode?
Yes, we'll do that. Okay.
There, perfect.
Okay, so thank you very much. We will talk about the Armington model. The title is Asymmetric Armington Model, Method and Application. And this is a paper that was published in the Journal of Global Economic Analysis. And in terms of the contents, we'll basically motivate you and present the model in partial equilibrium and in with a partial equilibrium example and a general equilibrium application. And I will take care of the first part. Martin will follow after me. So the Armington function is, of course, used in many CG models, and it's always being assumed that it's equally easy to switch to and from using imports in on the demand side. And what motivates this paper is that we think that it's very often easier to find close substitutes for domestic products abroad than it is to find close substitutes for imports among domestic products. If you think, for example, of an African country that has a manufacturing sector, if the import prices go down and you would like to switch toward more imports, it would be quite easy to find typically products that are similar to the ones that one were buying before from domestic products. But if you have you're moving in the opposite direction, that you would like, that you have to try to because of the higher import price, that you would like to increase your substitute domestic products for your imports, then it may be quite difficult, because many of these manufactured products that you are importing may be sophisticated, technologically difficult to produce at home. So for that reason, that's the motivation. So that's why we are extending the Armington treatment so that we get different responses to increases and decreases in the prices of imports. That's where the term asymmetric comes from. And it's clear to the GTAP audience that this is quite important, because the responses that you get in a model and in the real world to terms of trade shocks or other external shocks depends on these elasticities. And it also, for example, matters whether the imports and the domestic products are gross complements or substitutes. So the familiar Armington indifference curve, we show it here, and the thick Boulder line A prime BC, that shows the case of the symmetric case, and ABC shows the asymmetric case. So if you start out at B for the symmetric case, if you would have an increase in your import prices relative to the domestic prices, you will move up along the Boulder curve, and for the other case along the thinner one. And as you can see, it will be easier to, or more difficult to, switch toward imports if you in the asymmetric case. On the other hand, if you had a decrease in the import price, then you would have, it would be the same for the two cases. Now, what we then are introducing is a CS function with variable elasticities. These exist in the literature, but they have not been applied with this exact form, and indeed they have not been developed to address the cases where with changes in relative prices. They have been applied to examples like having different kinds of responses to increases and decreases in energy prices. We are using these CS functions in the calibrated share form, and that goes back to de la Grandville and Rutherford. So we are benefiting from their contribution, and the reason for using that is that it makes it easier to do the coding in GAMS, which is the software we are using when you have changes in elasticities. You would need to redefine more parameters if you were using the more common form for the CS function. The notation that we are using in the equations we show, you see it on this slide. So it's uppercase Latin letters for the different prices and quantities. QQ is the composite supply. QM and QD are quantities of imports and domestic sales. And then the P variables are there. Have the same second letter to show their meaning. This slide shows the CS function in the calibrated share form. So the composite, the first equation is the composite supply, and the novelty there is that you have the two share parameters, one for imports and one for domestic demand, and you see the definitions below. And then we have the cost function that defines the price paid by the domestic demanders. So those are the key or the standard equations for the calibrated share form. Now the key equations in the model that we are using are presented on the next two slides. And to capture the asymmetric Armington function, we have a mixed complementarity component in the model that include variables with upper and lower limits, and complementary slackness conditions. So the way it works is that you can see here that we have dev P, which stands for positive deviations, dev N for negative deviations, and those are non-negative variables. And a little bit to the right there, you have the endogenous elasticity variable, sigma Q. So it has to be above the lower limit and below the upper limit. And the top equation that defines the new simulated ratio between the import price and domestic price minus the original one. And if the PMPD, for example, would increase, then you would need to have a positive term on the right-hand side. And the only way to get that is to have dev P being positive. And then you can see, if you look at the complementary slackness condition, the next equation there, you will see that if dev P is positive, well, then sigma Q has to be equal to the sigma QL. So you get the lower limit or the lower limit for the elasticity. And if that is the case, well, then the dev N would have to be 0, and then you would also be forced to have a sigma Q minus sigma QH being a positive term, so that that complementary slackness condition would hold as well. So for example, for this case now, if we talk about PMPD going up relative to PM naught PD naught, we are at the right end of the figure you have at the bottom, and we could have moved in the other direction as well. And then the key equations that we are using in the model are derived from the typical cost minimization problem for the demand for domestic demand using imports and domestic products. And we have a QM, that's the demand function for imports, QD, the demand function for domestic products, and the cost function that defines PQ. And as you can see, we are using a variable in these equations. When we proceeded with this, the first thing we did was to set up a partial equilibrium model and to see how test that it really worked for the asymmetric cases and comparing it to the symmetric case. So we were developed this tiny model for one sector and a couple of equations, and we varied the price of import from minus 80% from of the base to plus 110%, and looked at the results. We used two elasticities, the lower level 0.5 and the upper level of 4. And for the symmetric case, we use 4 throughout. So here we are starting out. This is the import demand functions, and we start out at the price of 1. And for the light gray curve, that shows the symmetric case for the import demand function, and the asymmetric case has the same function for when the price declines below 1, but if it increases, then you get this steeper curve. So the approach indeed worked, and then I will leave this to Martin. Do you want to get the screen, or should I continue with mine?
Yeah, thank you. It's better if I have the screen.
Okay, very good. So then I will try to find stop share here. Okay.
Thank you.
¿Le puedes poner en presentation mode? Maybe you can swap.
Yeah, I did that.
Perfect.
Okay, so thank you. So what I will do now is I will show you some simulations using a general equilibrium model so that we illustrate the approach that Hans has presented. So for this application, we use a simple static CGE model. We apply the model to Mongolia. The assumptions that we make is that labor is perfectly mobile, capital is sector specific. For the macro closure, we assume that we are interested in looking at welfare impacts with this static model. So we assume that the real exchange rate is the variable that clears the current account balance. The savings clear the savings investment balance, and the income tax clears the government budget. So those are the assumptions for the macro closure that we are making. And we are calibrating the model with a relatively small sum social accounting matrix for Mongolia. It has 7 activities and commodities, and there is a one-to-one relationship between activities and commodities. Then we have 4 factors: labor, capital, land, and mining resources. Only 1 households. And we have, together with the households, we have enterprises, the government, and the rest of the world. So we have 4 institutions in this particular application. Okay, so let me. Okay, so together with the sum, we have the elasticities that we use in this application. You can see here the 7 sectors that we have in the social accounting matrix: agriculture, mining, food, machinery, manufacturing, industry, and other industry and services. We have the value-added elasticities, lower for primary products or sectors, higher for non-primary sectors. And then we have the Armington elasticity. For the low Armington case, we assume that the elasticity is 0.9. And for the high Armington case, we assume that the elasticity is equal to 3. And the CET elasticities, that's how we model trade on the production side. We have a constant elasticity of transformation function to select, say, how much is sold into the domestic market and how much is exported to the rest of the world. For the CET elasticity, we use 3, and we assume that the utility function is a Cobb-Douglas function. Okay? So the important thing is we use 0.9 for the low elasticity and 3 for the high elasticity, the Armington elasticities. Okay, something about Mongolia as we are capturing the economy in the social accounting matrix. This is data for 2015. And here we have data on shares of value added, employment shares, export shares, import shares. And we also have data on the ratios for exports to output and imports to demand. So we see how relevant is trade on the export side, on the import side for the different sectors. And from here, we learn that, for example, agriculture is important in terms of employment, less in terms of value added and exports. We see mining is a huge sector in terms of exports. See the yellow line, and it's also a very export-oriented sector. In the case of food, which is the sector in which we are going to focus on the simulations, food, we see that it's on the consumption side, we see that more than 20% of demand, and that's the blue line, is covered with imports. Okay, so 20% of total demand is covered with imports. And we see that total imports of food products, they are almost 10% of total imports. Okay, and then you have similar information for the other sectors. Let me continue. Okay, so we have 3 sets of scenarios. The last 2 are the ones in the paper. We have them here in an appendix. So I will be focusing on the new one, which is this is a scenario in which we decrease the tariff rate on food products. Okay, and we run the same scenario with 3 different models. In the first one, we assume that the Armington treatment is the symmetric one, and we assume that all the elasticities are the low elasticities. So they are all equal to 0.9. And again, the simulation is the elimination of the tariff on food products. Then we run the same scenario, but using the high elasticities for all the products. And the last one is the asymmetric treatment, okay? Which is, and I see now that the H here is not really needed, okay? So it's the asymmetric one, and again, it's the same shock. And then we have a scenario in which we increase the price of machinery, the import price of machinery and equipment, which, as we saw before, it's a huge sector in terms of imports for Mongolia. And then we have another scenario in which we eliminate the current account deficit. Okay, but again, I will be focusing on the first one. Okay, so these are the results. On the left-hand side, we have some macro indicators, the percentage change relative to the base for private consumption, exports, imports, and the real exchange rate. And on the right-hand side, we have the change in the PM-PD ratio, PDD, which the price of domestic product for the demander. Okay, because we have a supply price, a demand price. Here we see the ratio that is relevant for the Armington treatment. Okay, the ratio between the price of imports and domestic products. And what we see is that the price of food, this ratio for food products goes down because of the decrease in the tariff. For the other sectors, we see that the price goes up because of the real exchange rate depreciation that we need in order to keep constant the current account balance, which is the assumption that we are making. Okay, so we eliminate tariff, then there is a real exchange rate depreciation, and then we see that the relative price of food products goes down. For the other sectors, goes up. In the case of mining, there is a small increase relative to the base. So in terms of results, macro results, again, we have the real exchange rate appreciation. We see exports and imports increase. And what is interesting here is that, okay, if we compare the blue line with the orange one, that's the low Armington and the high Armington, we see that the higher the Armington elasticity, the higher will be the impact on trade. But then we see that for the asymmetric case, the impact is even higher for exports and imports than in the symmetric case. And that's related to the sectoral results that I will show in the next slide. And again, it's also interesting to see here that the difference is 10 percentage points in the change. And in terms of private consumption, or if you want welfare, we have similar results if we look at the equivalent variation. The difference in welfare is, again, it's around 10%. Okay, so the results are different between the asymmetric treatment and the symmetric treatment. Okay, and that's because when we look at the elasticities, the Armington elasticities that are related to what we see here on the right, see that for two sectors, particularly food, the model is selecting the high elasticities because the relative price of imported food is going down. For the other commodities, the relative price of imports is going up, so the model uses the low elasticities for those sectors. Okay? So these are the elasticities that the model is endogenously selecting when we use the asymmetric case. Okay, so then if we look at some sectoral results, what we see is that, okay, so there is an increase in the composite supply or demand for food. That's expected given the change in the tariff. And what we see is that imports of food goes up. That's what we have on the right-hand side. And what is interesting here is that when we compare the symmetric case with the high elasticity, which is the orange one, with the asymmetric case, which is the gray line, we see that the decrease in imports of non-food products is higher for the symmetric case, because we are using a high elasticity here in the orange one. Okay? So for the asymmetric case, the elasticity that that is being used for the non-food products is the low one. So the decrease in imports is smaller. Okay? So on the one hand, we have an increase in food imports that is similar to the symmetric case. But then for the other sectors, the decrease in imports is smaller for the asymmetric case when we compare to the symmetric case with high elasticities. And that explains the overall results that imports increase more when we use the asymmetric treatment relative to the case in which we use the symmetric treatment with high elasticities. And I hope this is, it's clear enough. Okay. I realize there are many asymmetric, symmetric, different cases, but I hope that the general idea is clear enough. Okay, and we can look at the domestic output. This is the domestic sales of domestic output. So here what we see is import. We have that the imports are substituting for domestic products that for food. In the case of agriculture, that's here there is an input-output relationship to the food industry. So given that there is a decrease in the domestic production of food products, that has an impact on the production of one of the most important inputs to the food industry, which is the agricultural sector. Okay, and for the other cases, we see an increase that is driven by the real exchange rate because imports of the non-food products are now more expensive. On the right-hand side here, we have exports. And again, given that the real exchange rate depreciation is higher when we use the asymmetric case, sectoral exports increase more in the asymmetric case when we compare to the symmetric case, even with the high elasticities. Okay, so again, this result is related to what we discussed before. Okay, so here the idea was to show you some results, to show you that it makes a difference to consider the asymmetric case relative to the symmetric case. And you have the other scenarios in the paper, they show similar results. And as a conclusion, I think that how important is the asymmetric treatment in a real world situation. That's an empirical matter. And so the next step would be for us to estimate, or for someone else to estimate these elasticities. There is literature that looks at different ways of estimating asymmetric demand responses. That has not been done in this context, but there is literature that shows how can this econometric estimation can be made. I mean, it's not really rocket science, but there is literature from which we can borrow to run the estimation and see how relevant this is in the real world. Okay, so if we found that the asymmetric treatment is a reasonable one, then that means that for countries it's more difficult to adapt to external shocks, negative external shocks, let's say. Okay, so we think the treatment is reasonable, but we still have to estimate the elasticities. Okay, so thank you very much.
Thank you, Hans and Martin. So now the floor is open for questions, and there is one already in the chat box. A round of applause reminded me by Jenny, and let's jump right into it. I can read it to you out loud. How to fix the low and high Armington elasticity? Is there any rule to fix low and high elasticity value, or is it hypothetically fixed?
You want to respond, Martin, or should I do it? Yeah,
you do it.
Okay, very good. No, we are not, well, we have to decide on what are the, for every sector, we have to decide on a on the two elasticities that apply, the high and the low, and that should be based on, just like in any other model, that it has to be based on the econometric estimation or the assessment of the modeler. What are these values? So we're not fixing it, but we need econometric estimates of the values that we are using. And we could, of course, also have that we have asymmetric treatment for maybe all sectors but so on, or we can mix the sectors so that you have both symmetric and asymmetric treatment. But anyway, it doesn't change the issue. So thanks for the question.
All right, and we have Dominic raising his hand. Dominic, do you want to?
Yeah, thank you very much. Very interesting presentation. I've been using something very similar for supply curves. Think about oil supply or gas supply, where it's typically much easier to reduce supply than it is to increase supply, depending on where you are on the supply curve. So if you guys are interested, you can look at the envisaged documentation where this is explained. Which leads to my second point. When you're working with very large models with a lot of complementarity conditions, it can lead to numeric issues where you kind of cycle back and forth between one regime and another. And I complained to Wolfgang about this, and he said that he replaced all of these mixed complementarity specifications with the logistic curve. And so I've implemented that also in Envisage. And it works really well. So you could think of a logistic curve where you have, your high and low elasticities. And what you want is that you want the transition from high to low to be very, very short. And you can do this with the kink parameter and set that parameter at a relatively high level so that you transition from the low to the high relatively quickly. So it may be interesting to do kind of the same exercise that you're doing, but using this logistic formulation rather than the mixed complementarity. Thank you.
Right.
Yeah, I think
any reaction? Yep.
I mean, that's a good. Martin, your turn.
Yeah, thanks, Dominic, for the comments. Yes, actually, the idea of using a logistic function for a similar thing, it's also in the 1982 book by Dervis, de Mello, and Robinson. They used that a logistic function, but on the production side. So we were thinking about that, but we will try to implement that. Thank you. Hans?
Yeah, no, that's true. I mean, because we were trying it out with a very small model. So if we are trying something like this in a global model, I could see that there would be some issues like the one Dominique raised that would come up. So good point. Thanks.
All right, thank you. There's another question through the chat box. Thanks a lot for the great presentation. One thing I have in mind is that GTAP sort of muted the distance elasticity, which might be empirically relevant to how you treat Armington functions. In counterfactual, could the simulation results be impacted by incorporation of explicit treatment of geographic features in the GTAP model, given that these parameters are all estimated?
Yeah, no, I'm not familiar with the distance elasticity. Are you, Martin?
No, I mean, I know you have trade costs in the GTAP data set, but here, I mean, maybe is the point to say that the Armington elasticity should be different depending on how close is one country to the other one? I don't know.
Anton, do you want to maybe unmute yourself and explain what do you mean by the question? Okay. Yeah.
Hi.
Go ahead, Anton. We can hear you.
Oh, thanks. So I was just thinking that empirically, the distance elasticity will estimate these parameters from the GTAP model. So if there is a distance elasticity at all, and so those should be associated with the Armington elasticities, right?
Can you explain what distance elasticity is? What do you have in mind behind that?
Yeah, just so I was thinking about the simple Armington model and Anderson-Van model. So you have distance elasticity associated with the parameters governing the substitution elasticities, and so if you empirically estimate these parameters and the treatment of asymmetric or symmetric actually matters for the empirical estimates from the demand function where you have distance elasticity incorporated in the model.
So,
Yeah.
so I guess the distance is the trade cost. Is that right? Distance is basically a proxy for trade costs, right?
Yeah, you can have a trade cost, or like you can. I think it is a trade cost, or like more like border the implicit border effects. And so if you empirically estimate these parameters, depending on how you treat the Armington functions, the actual magnitude of these estimates, whichever you might call it, distance elasticities, or the power function that in fact interact with the distance elasticity matter, right? So how you treat Armington functions. If you have asymmetric Armington functions, may have like a larger distance effect. And in counterfactuals, and I'm just wondering if we do this counterfactuals in the GTAP model, and whether the empirical estimates along with the treatment of the asymmetric or non-symmetric may be offset. Just if assuming that we estimate all these parameters consistently from the model assumption where we have both the implicit, the border effects with distance elasticities and our asymmetric Armington functions.
Yeah, I don't think we know the answer to that, but I mean, if you're estimating several elasticities at the same time, I mean, yes, it would matter how you do it clearly, but maybe that's a side discussion.
Right. So you might have so if you identify the other relative parameters in the asymmetric functions, and so if we think about the problem derived from the EK, where you have distance elasticities, and which is rho, and you also have these prices where you trade it at benchmark, as you can fix these prices and benchmark at one. And you can estimate these, distance elasticities based on how you trade the fixed the prices where you actually choose the quantities, right? And these parameters, the change of these parameters might not matter for counterfactuals, because in Deco Eaton-Corton, where you use the exact hat to eliminate explicitly these the relative forces of these prices, and you've got these shifters estimated along with the distance elasticities. So if you change the functional form in the Armington, where you have you had a symmetric function, now you change to asymmetric functions, and then you estimate these distance elasticities, and you will get a different set of distance elasticities, and that will likely yield the same counterfactual result. No, if you think about this, like I don't know, like simple Armington, you have you treat all these prices as one, the relative prices are one, and then and then you estimate your general equilibrium functions, and you get the relative the shifters, right? And you get the relative shifters, and these relative shifters, no matter how you trade the relative the prices in the beginning in the empirical work. So if I map this problem to a problem where you modify your Armington function from symmetric assumption to asymmetric assumptions, and these parameters that you estimate, if you do have the distance elasticity traded in the model, might not alter your counterfactual results at the end.
So I guess you could think of it perhaps in this single country model, that the one lower elasticity is between a country that is close by or distant by, and the high is the vice versa, and then you let the simulation choose between high and low. So
yeah. So I think a more general comment is, if you allow more degree of freedom in the parameter space incorporate in the model, and you may have other parameters to be adjusted in a way that the simulation result do not change. So you definitely in this case you have a one country model. Maybe it's my bad. I was thinking about, like, at least you have more countries, like multi-region. I'm trying to think how we extend this framework to a multi-country region model, right? And where you have more treatment in the model, where you can have this distance enter into your model. And if you estimate these parameters all econometrically at the same time, you may have up and down, just depending on how you treat the asymmetric or symmetric Armington functions.
Okay. Any comment, Hans or Martin?
No, I mean, it just seems to me that no matter how you do it, you may then, or you may want to rethink how you do the procedure so that you can capture the alternatives of having asymmetric or symmetric elasticities, if you think that is relevant, because it should continue to be just as relevant in this case, it seems to me. So, but you know more about these how these things are estimated than the rest of us, I think. So. But
Thanks, Hans. I'm sorry to ask these questions. I actually had one more quick question in mind. That how do you treat the rule of two in the model?
Can we give opportunity for the other two that are waiting?
Oh, of course.
Maybe type it up and then we get to it.
Yeah, definitely. I'm sorry. Yeah.
That's all right.
Sorry.
The other question that we have is also in the chat box. You guys can also read it. I'll read it out. In practice, is the asymmetric treatment always more close to the reality than the symmetric one? And will it be affected by the domestic productivity? Should we tackle that first, Hans or Martin?
Martin?
Go on, Hans.
Oh, okay. No, I think this is a separate issue, because here we are talking about, you could say a demand question, right? The choice between imports and domestically produced goods on the demand side, and how easy it is to make these switches, so that it's a changes in preferences that would lead this to change perhaps over time, or changes in the. No, I see what you're saying. I mean, changes in the. It's not changes in domestic productivity, but I could see that over time it could have, or it should have, to do with the product variety to a large extent. And if you're on the domestic production side, sort of start to get, let's say, become more diversified, so that you are able to you become better at replacing imports or producing goods that are similar to the imported ones, then these elasticities ought to be changing over time. But it's not exactly the productivity parameter. That's my reading into it, at least. Martin, do you have?
Yeah, I mean, one thing that will happen if there is a change in domestic productivity is that that change in productivity can have an impact on the ratio of prices that we are using to endogenously select the elasticity of the Armington elasticity. So in that sense, if there is a change in productivity, that can trigger a change in the elasticity, in the Armington elasticity that we're using for a given scenario. Yeah.
I guess it was also kind of like when you mentioned that over time, Hans, I was thinking that this will be different between a developing and developed country case, where the developed has perhaps more product variety already existing, versus where in the developing, where it really is the import quantities that it becomes a little, perhaps less substitutable, right? There's nothing in the domestic market to substitute against. But anyways, just I thought the next question, in one of your simulations, you have applied endogenous elasticity of substitution. What variable of production function becomes exogenous in this case? So I guess the question about the closure.
Yeah, but instead of fixing another variable, or of what we did is we added equations so that the elasticity is endogenously determined. So we have a new variable, that's true, which is the elasticity of substitution. So what we did is we added equations given that we have this new elasticity, this new endogenous variable.
Right. So you're not compromising anything or not swapping anything else. So
yeah, exactly.
Hopefully that is clear. And so we have time for more questions. I think, Anton, you had one. Do you want to unmute and raise the question?
Thanks, Angel. So I have basically the question linked to the invention of the rule of two, where Rob created that the theory in the GTAP model, and where the substitution elasticities within domestic bundles are twice as high at the cross country elasticity of substitution. I'm wondering if we extend this framework to multi-country region model, or like the standard GTAP model, how you think about this linking to your asymmetric treatment in the model.
I think we should proceed step by step to check that, work on the econometrics, see how relevant it is, and then think about what may be reasonable to do in settings where you have different levels of let's say trade in goods, and you may opt to do it just at one level, perhaps. I suspect. What do you think, Martin?
I agree. I mean, it's yeah. I mean, it's the treatment can be used in different settings. Right now, we are using it for trade and see how it goes from there. Yeah.
Yeah. All right.
Maybe Angel, if we can elaborate on this point that you raised. I mean, the question in general is that of the how similar are your import structures and your in the things that you're demanding domestically, how similar are these goods that come from imports and domestic sources, and how flexible is your production structure, right? So it could be that, as we said, the example that we have a low-income country that produces just very simple manufactured products, and you cannot possibly start to replace many of the imports. That would be an inflexible structure, and probably more advanced or higher income countries would have a more flexible structure in that respect, that the things that you could change what you're producing domestically and vis-a-vis your imports relatively easily. But you could also be, if you think about agricultural sectors, it could be that certain depending on climatic conditions and natural conditions and so on, that could be middle-income countries that find it easy to switch between replacing imports in both directions, whereas some high-income countries may be totally impossible to replace certain kinds of tropical products, for example. So it really depends on the specifics of each country, I think.
Right, and also and how detailed you go into your sectoral definitions, right? Because if you have agriculture, then it kind of masqueraded these tropicals with other products value. And it's something when we're thinking about maybe a developed country, then you have all these if it is just manufacturers, right? I mean, there can be a whole variety of manufacturers embedded in that category. So, but no, yeah, I mean, it's interesting. I mean, and the ultimate results that you obtain at the macro level are also very clearly depicting the Mongolian economy. So I like that you show us that first, kind of help understand the results given the final allocation of elasticities in the asymmetric case. So yeah, no, very, very interesting presentation. Thank you for that. If there's any other question, we have perhaps chance for one last, or maybe some final remarks from you too, Hans or Martin. I liked, that was kind of one of the things I was thinking, like, where do you take it from now, right? I mean, what is the next step? And you kind of already mentioned that.
Right, and I hope we are not throwing sand into the GTAP machinery now, that there would be lots of self-doubt about using symmetric elasticities, but I'm sure the switch will be smooth if you figure out that they, or if we find out that they are important, because it's an empirical thing here, and there's no particular reason to think that these elasticities are symmetric, actually. I mean, why would they be? So it's a shortcut, and maybe it's a valid shortcut or not. We'll see if we can do some econometrics on this. So thank you.
Yes, no, definitely. I mean, the work on elasticities is I think, in high demand and much needed. And we do kind of try to give some regional variation there, especially in the latest version of the model. But yeah, no, that's still just, there's still more to be done. So this is also very good to keep in mind. And so thank you for bringing it up, and you're looking forward for more applications on this work.